with circuits, when working with Ohm's law. So that will be very important for us to fully understand. So I am quickly going to give you another 30 seconds for you to be able to digest and just know what is it that Ohm's law is saying. I don't see any hands, so I believe that is now clear. So I am just going to duplicate the slide because I want now to emphasize other important issues that relates now to Ohm's law. R is equals to V over I. Ohm's law, we said now, other important equations or definitions. These definitions, we agreed that it is going to be ohmic resistor and non-ohmic resistor. So these two resistors, they actually now relate to Ohm's law. So I am quickly going to remove everything here. Draw a line and draw another line and be in a position of now explaining the difference between ohmic resistor and non-ohmic resistor. Non-ohmic resistor. Let's start with ohmic. Ohmic conductors that obeys Ohm's law. And obviously, this side a conductor that does not obey Ohm's remains the same or remains constant. And resistance of the conductor does not remain the same. Remains the same, does not remain the same. Can we assign this in terms of the graph? Yes, we can. And this graph will just be a straight line. Then one can easily say this is V and this is I. But when I look at this, if I look at the gradient now of this graph, it will be V over I, or changing V over I. But let me go back to this Ohm's law. The potential difference across a conductor is directly proportional to the current. So directly proportional means at this point and at that point and at this point and at that point, the gradient is the same. But now this gradient, what does it represent? Let's quickly check. R is equals to V over I. So actually what this gradient represents, this gradient represents the resistance, and the resistance remains the same. So let's write R is equals to R, which is equals to V over I. So by definition, the potential difference is directly proportional to the current in the conductor. What does that say? It says the resistance, it's the same throughout. So you will be given a graph, just understand the importance of the gradient thereof. So once you are calculating the gradient, or the question asks you to calculate the gradient, or what is it that the gradient of this graph is representing, it is representing the resistance of the conductor. Let me give you your 30 seconds for you to digest everything under ohmic resistor, or ohmic conductor for that matter. So this is the reason why it is so important for one to fully understand the difference between ohmic resistor and non-ohmic resistor. Feel free to ask questions. Feel free to raise your hand. There's such an option in the Google Meet, such that I can be able to assist you the best possible way I can. Thank you very much. I don't see any hands. I'm just getting worried that you are now not asking questions. Should I just say, Lesedi, is everything clear?
Yes, sir.
Nyakallo?
Yes, sir.
Okay. CDT?
Yes, yes, sir.
Thank you very much. Ratanam Pesho?
Yes, sir.
Thank you very much. So with that being said, let's try and do the same now for non-ohmic resistor. Can we draw a graph that is going not to give us the same resistance throughout? Let's see. Let's have a graph. And I am going to use this and just do it something like that. Then I say, okay, fine. This will still be my V. This will still be my I. Now, can one easily say the resistance is the same? No, we cannot. Because at this point and that point, you can get this particular gradient here. At this point and that point, you get now a different resistance also. Can you see? So it basically says the resistance is not the same throughout. Then we can easily say, but with that being said, one can easily say, but let's look at the gradient here, which will also be V over I. But the fact that this V over I, it's not constant. Not constant. It's when we say now it does not obey Ohm's law. Because for Ohm's law, resistance must be the same throughout. So if the resistance is not the same throughout, definitely, then we are in the wrong. Definitely, then we are missing a point of how Ohm's law actually works. So Ohm's law works provided that we have an ionic resistor. So for non-ionic, we cannot associate it with Ohm's law because it does not obey Ohm's law. Furthermore, power is also another important aspect that one must look into. What is power? We need also to have a definition. So when I come and tick the boxes of things that I need to know, I am happy with ionic, I am happy with non-ionic. I am happy now with Ohm's law. I must now come back and focus on power. Ladies and gentlemen, power is a very important aspect of electric circuit. Power contributes a lot of marks together with Ohm's law. But I will repeat and say, for us to work with power, it's important to know everything on this particular slide. So this slide is actually the slide of the day. Why? Because even if I am talking Ohm's law, it's either it's series or parallel. Even if I am talking power, it's also parallel and series. So I am going now to further explain in terms of power what happens when we have resistors in parallel, what happens when you have resistors in series, but with the bearing in mind the analogy that we said series connection are potential dividers. In parallel connection, resistors are current dividers. So that is very, very important. So I want you now to think and visualize this slide, because now what I am going to do now, I am going to explain in terms of power. So let me copy. Let me copy and delete to save time. And now we explain issues of power. Maybe in the meantime, now that this one is clean, I must just copy, and then have nice 4 slides. Then, ladies and gentlemen, let's get into power. Power is defined as rate at which work is done. The rate at which work is done. Okay, let's explain. Rate is a measure of time. It is a measure of time. And what is work? Work is energy, ladies and gentlemen, energy. And this energy is measured in joules. The SI unit of power, SI unit of power is what we call watts, and just a big W. Already from the definition, rate at which work is done. Can I derive a formula from that? Yes, one can, to say P, which is power, is equals to W over T. So P is equals to W over T. Let's see if this assists in terms of understanding the relationship between Ohm's law and the relationship now between power. So power is equals to W over changing T. Already from the definition, rate at which work is done. So in simple essence, one can easily say what basically means joules per second, the amount of energy that is lost over a second. So mind you, this must be in seconds. This must be in joules. Already it is one equation of how to calculate. But there are other three important equations that one must think of. The other equation is P is equals to VI. The other one is P is equals to I squared R. The other one is P is equals to V squared over R. Allow me to highlight and put this into a rectangle for purposes of emphasis. For purposes of emphasis, and we make it nice and blue. Now, you cannot just randomly apply these equations. You cannot. You need to have a system that is working in order for you to be aware and know exactly which equation is relevant for you to use. Allow me to say, if this is information that we need to have of power, can we relate it to this particular slide? Most definitely we should, because I did say that this slide now covers majority of the work and things that we are going to do. Let's check. I am going to redraw this for purposes of emphasis. Let's see. I am going to say we are still busy with power. But I am going to say I'm still now connecting my resistors in series and my resistors now in parallel. Let me draw again resistor 1 and 2. R1, R2, R1, R2. just for only to remember. Let's look again. What did we say? We said I total is equals to I1 is equals to I2. We said I total is just I1 plus I2. We said R total is just R1 plus R2. 1 over Rp is equals to 1 over R1 plus 1 over. What did we say about V? V total is equals to V1 plus V2. V total is equals to V1. V total is equals to V1 is also equals to V2. These are just standard and basic information that you might already know. But I am going to introduce the element of power. Introducing the element of power wants me to understand that the current passing at R1 and R2 is the same. That is very, very important. V total equals to V1 equals to V2. Let's move. If we move, we are going to say current is the same in both R1 and R2. It's the same. Now this side, current is not the same for both R1 and R2. Why? Because we did say R1 is not equals to R. So immediately now that we have difference in terms of resistance, then this makes it easy for us to know that definitely the current passing at R1 and the current passing at R2 are not the same. That is very, very important. So I am going to highlight because we need this in order for us to apply the following statement or information. If that is the case, the only relevant equation here that will help me or assist me is the equation that is P is equals to VI. At the very same time, P is equals to I squared R. So these two equations are the equations that I am going to use when I am given resistors in series for calculating power. One will ask, but you said we have three equations. The other one is P is equals to V squared R. Okay, fine. I did say so. But with that being said, I am also trying to eliminate distractors, equations that are not going to assist me in terms of explaining. Let me do the same this side. The relevant equations will be P is equals to VI and P is equals to V squared R. I am going to explain now. Me explaining this, I am going to say, but if I have P P is equals to V squared R will not be a fair comparison. Will not be a fair comparison. What does that mean? Ladies and gentlemen, let's look at this. R is changing. That means R1, R2 are not the same. V2 or V squared is also changing because V at 1 is also not the same as V at 2. So in physical sciences, one must remain constant such that we have now what? A fair comparison. Maybe this becomes an unfair comparison only because both V and R changes. So we cannot have a both variables changing for us to compare, because the question will be compare the brightness of R1 to that now of R2. So for you to compare, you can only use the equation P is equals to I squared R. Why? Because current is the same in both R1 and R2. One variable must remain constant. That is very, very important. So in this instance of resistors in series, the only thing that is constant is now what? The current passing through R1, the current passing through R2 is basically now what? The same current through R. It will not be a fair comparison. The reason now being both V and R changes. Both V and R changes. Can we do the same this side? Let's try and see. Potential difference is the same for both R1 and R2. It is true. We proved. We used the analogy that we know of science and the application of Ohm's law to say Vt is equals to V1 is equals to V2. So the only thing that is changing here is current and resistance. So what can one say? If this is the case, one can easily say, fine, then which equation will be relevant? We did say the equation is P V squared over R. That allows us now to be in a position of fully explaining what is happening in terms of power. So my emphasis is check these two important equations for parallel. Check now these two important equations for series. So I am going to pause, give you your 30 seconds and deliberate more on power. And please ask your questions such that I know that we are on the same page.
I'm sorry, sir. Can you please explain the comparison both V and R changes?
Okay, I will do so. Thank you. Noted. Any other one? Thank you. Let me explain. Check. V1 plus V2. Obviously, V1 and V2 are different. V1 and V2 are different. So if V1 and V2 are different, then it basically says if we are going to compare the brightness of R1 and R2, it is going to be very difficult because you have the V that is changing. You have the R that is changing. Remember, R now is resistance. And we did say R1 is not equals to R2. So the fact that R1 is not equals to R2, that basic concept that says V total is equals to V1 plus V2, it basically says I am going now to have two things that are changing. So I cannot compare the brightness of R1 and R2, whereas both of them have two different variables that are changing. So preferably, let's have one constant variable. And that one constant variable is now what? It's current. Hence, I highlighted to say I total is equals to I1 is equals to I2. So that it's being explained by this important slides, by this important slide that explains how the operation plan works in terms of a series connection, in terms of a parallel connection. So basically, you cannot use P is equals to V squared R because both V and R are changing. So what is going to come after is to say how can we make it now to be a fair comparison that the number. That is now what we are going to deliberate more after this 30 seconds. So I am quickly going to say, Lesedi, your hand is up.
Also, that by accident, sorry.
Oh, okay. Thank you very much. But I hope I explained now why can we not use P is equals to V squared R. We cannot use that one.
Oh,
Motewo,
okay. Thank you, sir.
thank
Yes, thank you. I understand now.
you very much. Nyakalo, are you still there?
Yes, sir. I'm good, sir.
Happy with everything so far.
Yes, sir.
All right. Bonolo,
So I'm fine.
if you are fine, I am also fine. Thank you very much. Ratanang,
I'm okay, sir.
thank you very much. Now, ladies and gentlemen, I am going to give you this instant approach of how to get the maximum of 4 marks. This question has been asked and asked and asked again. As one of the people who are setting papers in the Free State, we are consistently going to ask it. The reason being, learners are still not getting it right. Compare the brightness of R1 and R2. Choose between increase, decrease, remain the same, something like that. And then it further says, explain your answer. Ladies and gentlemen, this that I am going to write down, you cannot change it. You must write it as it is. It is going to assist and help you to be able now to get that maximum of 4 marks. If you want now to manipulate it according to your understanding, ladies and gentlemen, believe you me, you will not get 4 out of 4. So I am going to give you this as a special treat from the Nambani Academy. Let's check now. first things first, you must say according. This is very, very important. According to P, sorry, according to P is equals to I squared R. The greater the resistance, the greater the power. Does it make sense? It should make sense. Only provided that we have the same current throughout. That is the reason why I explained to say it is important to understand how the current flows in a circuit. The greater the resistance, the greater the power. Greater the power. But it is important to say for the same current. So the current that is passing there is the same. Remember, I said the red represents the current. So the current passing there and the current passing there is the same. So according to this equation, P is equals to I squared R. Because remember, we are comparing now. So the current will be the same, but R will not be the same. So the one with a bigger resistance will produce now bigger power. So it basically says the brightness in series is influenced by the bigger the resistor. So if I want more power, I must have now what? A resistor connected in series that will give me now what? A bigger power. And it makes sense because one can also say using P is equals to VI. For greater resistance, for greater resistance, V also increases. And it makes sense. Why does it make sense? It makes sense because we are going to use Ohm's law to understand that. So if you have a greater resistance, you also have a greater V. So according to that equation, P is equals to VI. The bigger the V for the same current, the bigger the power. So these two bullets, you take them as they are and you just plug them in the examination. So with that being said, I am going to pause and take a question from Moteo.
Okay, sir. I just want to ask for the according to the P equals I over R, right? Would we say greater than, because the greater the resistance, the greater the power?
So what's the question? What are you asking basically?
would you then say it is greater than for the according to the P equals I square O
I squared R.
R?
Okay.
Yes, sir.
It, thank you very much. It's a very nice question. Remember, with reasoning, especially when the question comes in a form of explain your answer, we want to explain our answers in relation to the physical science principles. So the physical science principle in this instance is that according to part. If you do not have according to P is equals to I squared R, I will not give you a mark. Because P is equals to I squared R is the reference of explaining that, but if I am going to use this equation, the only thing that is changing there will be resistance. So it makes it a fair comparison. Immediately after it being a fair comparison, we explain now to say, but now the one with the greater resistance will have the greater power. But it is also important to say it must be for the same current. But the same current works when you have P is equals to I squared R, because the current passing at R1 is the same current passing at R2. So if you omit that equation, believe you me, we will not give you marks at all. Is it clear, Moteo?
Yes, I understand that, sir, but that's not necessarily wanted to ask. I wanted to ask for like the first part of the 4 marks. Would we say that it is greater than?
Oh, okay. No, you'll be given 3 options: greater than, smaller than, remains the same. Then you must commit to say it's greater than. Let's say that. Ne?
Oh, okay.
Now you must explain why or how you came about choosing that it is greater than. So after saying it is greater than, then you come to this explanation of according to this to support your choice of answer that the examiner gave you. At times will be greater than, smaller than, things like that, increases, decreases, or remain the same. But for you to choose which one is correct, you need to have proper reasoning. You cannot just say it's greater than, and then the question will be why? How can you tell? Then you use now the segment of according to P is equals to I squared R. You continue with the sentences that are there. You add the second equation, which is now what? P is equals to VI. You also explain now that the greater the resistance, the V also increases. And for the same current, then it basically says the one with a higher voltage will give us a higher power or a greater power. So the choice will still be there, greater than, smaller than. But my point here is because we do not have a question as yet, we are only explaining the concepts. Once we are able to understand the concepts, it will be easy to apply them in an examination. Happy Moteo?
Yes, sir.
Thank you very much. Let me see who is here. Baanetsi, are you still with us, me?
Yes, I am.
Everything clear?
Yes, sir.
Thank you very much. Ladies and gentlemen, let me not waste time, but that section or the part that I explained is very, very, very important. I'm going to do the same now for parallel. Kindly be with me such that we fully understand this. In these 2 hours, this topic will be finished. Tomorrow it will be more of an exam kind of setup. We now apply these principles on a previous paper, but the topic will be done. And mind you, everything that you do in school, I think this topic you are doing it for 2 weeks or 3 weeks. So I'm compressing everything in a nicer way for you to be able to finish early, have systems in place such that now you can start improving your marks. Maybe I must just check. Ratanang, have you done this topic at your school?
So we haven't done this yet.
Okay, that is very good. I chose it deliberately so that when Mr. Tenji do it later around May, then you guys already are somehow ahead and then it becomes revision. If I am going to do other things that needs to be done in this term, definitely then it means we are going to complete the syllabus very early. That's the plan. Nyakallo, let me check at prep now with XTN. Did you do this?
No, sir.
Okay, let me also check. Bonolo, you are from
Sir, I'm from St.
St.
Michael's.
Michael's. I want somebody from Dr.
Yes.
Filjun. There has to be somebody from Dr. Filjun here. Shanice is not here. Okay. No, thank you very much, ladies and gentlemen. Let me get into it. It is exactly 19:30, and the intention was to finish everything by 8 o'clock. So I need now to rush. What about now when they are connected in parallel? We must start and say now, according to P is equals to V squared R. It's a different equation now for parallel. Why P is equals to V squared R? It's clear. The only thing that is changing here is R, because we agreed, we agreed that P, not P, V total is equals to V1 is equals to. So the potential difference is the same. So one variable must remain the same. So the only variable that is changing is R. Hence now, according to this particular equation. So I want you to see the importance of understanding this basics of Vt is equals to V1 is equals to V2. Let's see now. Let's see now. Then we can easily say the smaller the resistance, the greater the power. The smaller this pen doesn't want to write. I don't know why. Let me explain. The smaller the power, the smaller the resistance, the greater the power for the very same potential difference, because the potential difference is remaining the same. So the smaller guys, you must tell your parents to invest in a new laptop. This one is dying now. The pen does not want to write. The smaller the resistance, the greater the current, according to P is equals to VI. So the smaller, I am not sure what's happening. You guys. Ladies and gentlemen, because of this pen that doesn't want to write, and it is exactly 1935, I believe with the powers invested in us, that means me and you working as a team, we can easily decide and say, let's finish off this session now and not bombard you with a lot of information while I am trying to fix this. I will want you to give me a feedback. The smaller the resistance, the greater the power. The greater the power. For the same voltage. Now, we further say now the smallest resistance, or the smaller the resistance, sorry. The smaller the resistance, the greater the current, according to P is equals to V. And that is true. Because with that already, it allows us to actually know that when I have resistors in parallel, the one with the smallest resistance will have the greater power. But the explanation thereof starts from according to P is equals to V squared R. So already the 4 marks is covered. The only thing that I need now to worry about is basically what? It's just an issue of which one is, like, which connection am I comparing? Am I comparing series or am I comparing parallel? So once that is done, believe you me, everything will become very, very easy. So easy means we have a system that we can use to approach all this sorts of information thereof. So with that being said, I need now to give you your 30 seconds to digest everything on the slide. But believe you me, we are building towards understanding the exam type of questions. But this system that we have, it is a system that will assist us to know and prepare fully for the examination thereof. So I'm going to give you 30 seconds, then you can ask your questions in detail. much. I don't see hands, I don't see questions. It basically says we can move. So the last part that we must work on is what they call the cost of electricity. The cost of electricity is just an easy concept that they introduced for us to understand now that why our electricity is becoming low and low because of the lights that we use, because of the cooking that we do, television and everything. So we introduced this concept in order to bring the element of realistic approach to physical sciences. So cost of electricity. So to calculate cost, you just say cost is equals to the amount of kilowatt hour. The amount of kilowatt hour multiply by the tariff thereof. So what is the tariff? The tariff is the amount that you pay for 1 unit of electricity. So its cost is equals to the amount of kilowatt hour. That means now it is power multiplied by time multiplied by resistance. So I am trying to sort out the pen again, but let me use my mouse so long. It is cost is equals to kilowatt hour multiply by tariff. So kilowatt hour is basically power. But now this power must be in kilowatts. So how do we get it in kilowatts? We multiply by 1000. So what is the tariff? The tariff is price, and this price, it is now in rands. This is now price, and this price, it is in rands. But kilowatt hour, then it basically says we must multiply whatever we have in terms of hours. So what we do there, it will be very easy. We must multiply the power that we calculated. We must multiply it with hours. So if I am given time in minutes, I must convert that time into hours. So what is important here is to understand that it must be in kilowatt, it must be in hours, the time that will be given, and the money or the price must be in rands. So with that being said, we can be able now to calculate the cost of electricity. So this is important because basically what we need to do is to use these equations of power. P is equals to VI and P is equals to P squared over R for parallel. For series, we must use now P is equals to VI and P is equals to I squared R for series. Then we will be able to calculate the power. Whatever power that we get, we are going to get it in terms of watts. So we must just multiply it now by 1,000. So watts to kilowatts, you multiply by 1,000. It's as simple as that. So furthermore, this brings us now to the end actually of this topic, which is electric circuits. So if this is the end, what is it that we haven't done? We have done everything, we even expanded, but what is critical is now we must do more of the application. So tomorrow we are going to work with previous exam questions such that you do your calculations, I calculate. We are going to use now this slide also for us to be able to perform different sets of calculations. So this is important in a sense that we know that the concepts have been explained fully. And now that the concepts are explained fully, what must we do? We must see and practice and perform calculations and so forth and so forth. So ladies and gentlemen, with that being said, this brings us now to the end of today's session. The time is exactly 1950. We're supposed to stop longer in grade 10. Now you are grade 11s, so we are preparing you for grade 12. So be ready for these long hours, which means 2 hours every Monday and Tuesday. But remember, if you request the recording, it is available. And remember, there are also other extra resources that you can get, and this you get now from my website, which is nambaniacademy.com. There's a lot of nice things that you can get there that will assist you in terms of short notes, summaries, even the very same previous question papers that I'm talking about. You'll find them there with memos and everything like that. So kindly visit the website, tell a friend, make us go big, because the intention is to help you the best possible way that I can. Earlier this year, I closed the school because of other personal engagements that I had, but the calling said somehow things must come back. Learners are definitely struggling. And so guys, thank you very much. For those that worked with me last year, I see a lot of improvement. So let's continue improving. And I'm happy that we started early. I'm also thinking of somehow near future, we are going to have face-to-face session where you can actually see this man behind this voice and all these nice things that we are doing. So Lisedi, kindly give us today's feedback and we will be able to close. Let's start with you, Lisedi. Today's feedback, engagement, what's your take?
So I was able to learn more about power, which we have never gone in depth with in grade 10, and I was able to learn more about resistors in series and resistors in parallel.
Okay, thank you very much, Moteo. Feedback for today.
I was able to learn a bit about the ohmic and non-ohmic resistor. So I think that is. I just would like to ask something about the non-ohmic graph, sir.
Okay.
Can it be in any different what you call it, any different form, like say for instance it is switched around in a way, and it can still be considered a non-ohmic resistor because the motion is not remaining the same, the resistance.
Let's just say the graph will not be a straight line. So as long as it's not a straight line, it's a non-ohmic resistor. Once you get a straight line, then it is ohmic resistor. So they can switch what is this, the axis, like now you have on the v on the y-axis we have V, which is potential difference. On the x-axis we have current. It can be the other way around. It can be current and V on the x-axis, but once you see that it is not a straight line, it is an indication that is an non-ohmic resistor. So even if I can switch the I and the V, but once I get a straight line, definitely that is an ohmic resistor. So the key thing is it must not be a straight line.
Oh, okay. Thank you, sir.
Thank you very much. Nyakalo, feedback for the day.
Sir, I'm not gonna lie to you. Like today's session was like very boring because like the work that we did is like we have been doing it since grade 9, so I wasn't really there yet. Yeah, but it was really nice. Like I appreciate all like the definitions you gave me. They are way better than the textbook definitions, and I learned a few new things. Thank you, sir.
Thank you very much, sir. Remember, I said yes, it must be boring because some of the things are from grade 8, grade 9, grade 10, grade 11. But let's see tomorrow if it is going to be still boring or even more challenging. Because the way I do things is the foundation must be there. I didn't want to assume that you know the connection of parallel, you know the connection of series. Because tomorrow I want to say, but I said so, says that I confidently know that it's something that we did together. So the basics are always important. Bonolo?
So I've learned quite a bit. I really appreciate you going through power, which we haven't done. So it gives us a head start before everyone in class. So, yeah.
Yeah, thank you very much. Ratanang?
Sir, most of the work, okay, some of the work I already knew, but the power and the Ohm's law was something new for me. So, yeah, I hope to learn more about that.
Thank you very much. But Anetsi?
So I appreciate that I was able to do some revision and refresh my mind about certain things, and I learned quite a lot today. So that's all.
Thank you very much. Ladies and gentlemen, with that being said, let's meet again tomorrow at 1800. Bring your calculators, bring your pencils, your erasers, and everything like that, so that you can make the session fast and quick. The idea is expose you now to exam type of question. Ladies and gentlemen, be on the lookout. I want to create an online register that you will complete. I believe it should be ready for tomorrow, such that now I can be able to follow it up with the people that are not here, like Shanice is not here. So it is important to ensure that definitely each and everyone is here, because now the parents are spending their hard-earned cash to to be assisted. So it is important that everybody must be there. So I see said you are saying I must add this number. I will add it once I am done here. You will also get the PDF notes like I promised. So you'll definitely get. Bonolo?
Sir, how many times do we have lessons in a week?
Monday and Tuesday.
Okay, thank you, sir.
2 hours, 2 hours, and then we are done in a week. Because Wednesday and Thursday is grade 12s. Okay, thank you very much, ladies and gentlemen. Let's meet now tomorrow May the great Lord bless you and give you strength and all the things that you desire. From me to you, thank you very much and have a lovely evening.
Thank you, sir.
Bye, sir.
You too,
Thank you, sir. Bye,
sir.
sir.
Bye, sir.
Bye, sir.
Thank you, Baba.